Okay, so I'm going to work through quiz from week 4, and I'm going to use the values I got as I previewed the quiz. Okay, so this document's available in I think it's week 5, maybe it's week 4 module. It should be the quiz. I put the document in there, and then that'll be the video. So the first question is slope of the line and the equation. So that's the equation of the line. B is the y-intercept, M is the slope. So I have values of 0 and 27.7, 13.5, 40.1. This is x, y, x, y. So my slope is rise over run. Y minus y over x minus x. So we have M equals rise of 40.1 minus 27.7 over 13.5 minus 0. And if I multiply that out, 40.1, 27.7 minus 13.5 divided by, I get 0.919. And so if I want the equation of the line, it's going to be y equals 0.919 x y-intercept plus 27.7. And then the answer you submit is the slope. Okay. Given that A is 14, so I can see that this is constant. So if it's constant, I can use the constant kinematics. Determine the position S when T is 19, if V is 9, and S is 41 when T is 0. So I'm given that A equals 14, and I'm given that at time equals 0, my velocity is 9, and my position is 41. Those are my boundary conditions, and I want to know what's going on at t equals 19. What is my position S at t equals 19? So I can use S equals S naught plus V naught t plus 1/2 AT squared. S equals position, 41, plus 9 times 19, plus 1/2, 14, and then I ran out of room, 19 squared. And if I solve this out, so I have 41, 9, 19 times, 7, 19 times, plus, I get S is 2739, whatever my units are, feet. Okay. A particle has an initial velocity of 5.1, so I know that I have a velocity initial of 5.1, a constant acceleration of 3. I want to find something when t equals 12.5. I want the position, okay, initial position of 36.4, and then t equals 12.5. So I can use the same S equals S naught plus V naught t plus 1/2 AT squared, and S equals 36.4 plus 5.1 times 12.5 plus 1/2, 3 times 12.5 squared. 36.4, whoops. There's something wrong with my calculator, and I'm kind of frustrated because I don't have to buy a new one because I looked on eBay and they're pretty expensive. Gosh dang it. Okay, hold on. I'm sorry about this, folks. This is pretty much the story of my YouTube life. I think, there we go. Okay. So, I have 36.4, 5.1 enter, 12.5 times, 1.5 enter, 12.5 times, plus. So I get S equals 334 to the nearest whole number, 335 meters. Okay. So let's go to my question 4. Question 4, write the equation of the line. What is the slope? So again, equation is y equals mx plus b, where b is the y-intercept. So we start with 0 and 103.2. That's an O. So I know that the y-intercept is 103.2. And b, I'm at 57.4 and 30.1. X, y, slope is rise over run, and I go from B back to A. So let's look at our slope. I also know it should be negative because we're going down, so I have M, rise, 30.1 minus 103.2 over run, 57.4 minus 0. So I get a negative 30.1, 103.2 minus 57.4 divided by 1.27. So that would be the answer I enter, minus 1.27x plus 103.2. Okay? So now we have the next question. Given the acceleration as a function of time, determine the total distance traveled. Well, this is where it's super convenient to understand the charts. The area of acceleration equals velocity. Area of velocity equals position, total position. So if I'm told that A is 5.7, so this has to be half of that, and this is 5.7. So 5.7 divided by 2, 5.7, 2 divided by is 2.85, so this is minus 2.85. And my time is 9, so I have 9, 18, 27, 36. Area equals 9 times 5.7. Area equals 36 minus 18 times negative 2.85. So we have 9, 5.7 times 51.3, and then I have 36, 18 minus 2.85 times minus 51.3, super convenient. So my velocity is going to go up, it's going to go over, and it's going to go down, and I know that it goes up to 51.3, and then here it's going to be 51.3 minus 51.3, so at this point it's the total area under the curve, which is 0. So now I can find the area of this to get my position change. So I have 9, 18, 27, 36. Area, 1/2 base times height. 1/2 base times height. Area, base times height, plus 9 times 51.3, plus 1/2 base times height. So 0.59 times 51.3, 9 51.3 times, and then 9 51.3 times, plus my position change is 1154.25. As a whole number, 1154. Okay, so of course that's all assuming I'm doing my math right. 1/2 base times height, and then 9 times that, and then 1/2, 18 times height. Okay, given the following, determine the equation for velocity and evaluate it for t equals 2 seconds. So given the following, find equation for velocity. Well, if I'm given s, then I just take the derivative of s with respect to time to get velocity. So I have 22t plus 14, 2.7. So 22, 2.7 times, plus 14. 22, 2.7, 14 plus 73.4. There's my answer. So now we have position, one of these guys. And if I look at this, when t is 0, I'm at 22. So I'm at A. So we're at 22 at t equals 0. To the left in 5 seconds, it travels to B. So time equals 5. And we've gone to 80. And that's negative 22. And then we come back to the origin in another 9 seconds. So the whole path, the whole time, is 14. Average velocity. So our average velocity is displacement over time. And when I look at this, I end at the O, or 0. So my SD is 22. So I have 22 over 14. .57. Okay, given the acceleration, determine the velocity at t equals 45. So we have 5, 10, 15, 20. Okay, that can't happen. That should not be 45. My guess is I had Canvas set up to make this 4 times 5, which is 20. And so that should be a +1 for everybody, because that's not solvable. So let's pretend that it said 4 times 5. I thought it would multiply in Canvas, but clearly it doesn't. So if I have 15.9 is A, then this is going to be negative. So we have negative 7.95. And if I want to know the velocity at this point, again, it's area under the curves. So area is 5 times 15.9, and then I'd have area of 0, and then I have area of 5 times negative 7.95. So if I graphed my velocity, it would go up, it would constant, and then it would come down halfway. So I have 5 times 15.9. So 79.5, and then I have 7.95 times, so this is 39.75, so this dot right here is going to be the original velocity of 79.5 minus this velocity, 39.75, that's the area under the curve, and I would be left with 79.5 39.75 minus, they should be the same because this is 5 and total, and this should be half with the same amount. So 15.9 time is 5, 79.5. Okay, 15.9 divided by 2, 7.95. 7.95 times 5 is 39.75. So I should go up to 79.5, constant velocity, and then I'm going to subtract off this area, and I get 39.75. So that would be my velocity at that point. Okay. A particle travels. Particle travels from 2. So S original is 110.1. S final is 592.8. The time is 12.2. It has an original velocity of 15. It has a final velocity of 79.1. Find A. Well, V equals V naught plus AT. 79.1 equals 15 plus A times 12.2. 79.1, enter, 15 minus, divided by 12.2. I get an acceleration of 5.25. Okay, next problem. Given the following, determine the initial velocity. So I have an initial position of 45. I have a final position of 117. I have a velocity final of 19.4 and a retarding acceleration. So this is position, no time involved. So v squared equals v naught squared plus 2a s minus s. So this always comes in handy when there's no time. So I have 19.4 squared equals v naught squared plus 2 times negative 7.4 times 117 minus 45. So 19.4 squared, and then I'm going to take this to 7.4, change signs, times 117, 45 minus, times. So I get 376.36 equals v naught squared minus 1065.6. Bring that over. Change sign plus. And I get 1441 equals v squared. Take the square root, and I get v is 37.97. Okay. Determine the acceleration given the following velocity. So acceleration is the slope of the velocity in this region. Okay. Determine for section A, given t equals 2, and velocity is 42.1. So I just need the slope of the line. M equals rise over run. So it ends at 42.1. It started at 0 time 0. So I get 42.1 over 2. So I get an acceleration of 21.05. Except I can't look at my entire slope. That's 4. Sorry about that. 2, 4. So it should be half that, I guess. 42.1, 4 divided by, I get acceleration is 10.525 hundredths, 10.53. Okay? When t equals 0, a particle is at a point which is 34 to the left. So I'm at negative 34 at t equals 0. In 2 seconds, it travels to B, which is 20 meters to the right. Oh, you can't see my work, sorry. In 20 seconds, it goes 2 meters, which is right. In another 5 seconds, it travels to point C, which is 31 to the left. So that is at negative 31. Time equals 5. So there's my path. What is the displacement? Well, the displacement is final minus initial, so my displacement is 3 meters. And next page. Oh, that's the end of the quiz.